So in the last video, we were talking about how to graph exponential functions and figuring out some of the shifts. So one of the things I want to reiterate is that exponential functions have a horizontal asymptote. So that means it's going to, as the graph continuously grows, it will get closer and closer to this y value. So in this case, both of these happen to have a horizontal asymptote at y equals 0. And so you can find it by looking at the vertical shifts. So in this case, there was no vertical shift, so it's at y equals 0. Or you can look at make a t-chart and predict where it's going to be located by how it's slowing down or speeding. In this case, slowing down would probably be the correct way to explain things. So let's get into practicing some of these graphing skills in example one. So in example one here, we are looking at, so we're looking at this equation here, f of x equals 3x. And so if I want to graph this, I need to make probably a t-chart so I can plot some points. I always recommend at least like plot 3 points when it comes to exponential functions. So that way you get a better graph. But we're also going to need to write down some characteristics like the type it is it decay or growth? Is it increasing, decreasing? Where's the y-intercept? The horizontal asymptote, domain, and range. So first off, let's talk about making a t-chart. So if I were to make a t-chart here, one of the strategies I use is to always choose 0, is because you have to find the y-intercept anyways. So the y-intercept is where x is equal to 0, and then you have to find what y value it is. So might as well just plug in 0 so you can find the y-intercept. And then I might pick like 1 or 2. And so those will be my numbers because they're easy to plug in. I'll pick some numbers that are easy, but you can pick any numbers. But I recommend choose at least 3 and always choose 0 to plug in since you have to find the y-intercept. So once I have these values, it looks like my base here is 3. So without even drawing anything, I can kind of predict that this is going to be an exponential growth because the base is greater than 1 and my x is positive. So I'll probably have an exponential growth, but I will double check once I draw it. So it looks like I'm plugging in 0 for x. So this is going to be 3 to the 0 power, 3 to the first power, and 3 to the second power. So I've plugged in my x values into the equation, and I'm ready to find the numerical value. So 3 to the 0 power is just 1. Anything to the 0 power is just 1. 3 to the first power is 3, and 3 to the second power is 9. So I have my x values here and my y values now. I'm ready to plot this on my graph. And it's okay if you go off the grid a little bit. That is perfectly fine. So at x equals 0, it's at 1. At x equals 1, it's at 3. Oops, 3 is a little bit higher. There we go. And then when it's at 2, when x equals 2, it goes all the way to 9. So I'm going to extend my y-axis a little bit. And then at 2, I'm going to try to hit it at 9. So I've just extended it and mark it at 9. You don't have to be perfect and extend it all the way out. Just mark where it's supposed to be. And so from here, I can draw the graph. Now, because there is no vertical shift here, that tells me that my horizontal asymptote is going to be at y equals 0. Actually, I probably should have just done that first. So my horizontal asymptote is going to be at y equals 0 because there is no vertical shift. So just as a quick reminder, the vertical shift tells us the horizontal asymptote. So I know that this is going to be at y equals 0. My y-intercept is where I plugged in 0, and my y turns out it's 1. So the y-intercept is at 0, 1. I need to graph the line here. So this side's curving upwards. You can kind of see that growth already. And this side is going to get really, really close to the asymptote, but not quite touch it. So you never want to try to touch the asymptote, trying to glide across it. And so this is definitely an exponential growth. And I would say that going towards the right as x's go to positive infinity, this is definitely increasing. So I would say this is an increasing curve. As far as domain, the nice part about exponential equation is that the domain is always going to be stretching um, on the negative x axis. So it's going to negative infinity, and this side's pointing to the right with an arrow, so it's going to be going to positive infinity. So the domain for all exponential function is negative infinity to positive infinity, or you can say all real numbers and use the fancy R symbol. As for the range, that's where it gets cut off because you can see the lowest point on this curve is where y equals 0. So it's the horizontal asymptote is restricting things. So the lowest that this graph can go is y equals 0. And it can't touch y equals 0, so that's why I'm going to use a parentheses. And then the highest point it can go to positive infinity for y. And so it's going to go from 0 to positive infinity. And you want to use parentheses just because you have an asymptote over here. So you can't touch this line at y equals 0. And then infinity you can never touch, so you always use a parentheses. And there we go. We have our graph. All right. So let's try the next one here. And what I usually like to do is first take a look at the horizontal asymptote. So I noticed that there's a -2 here. So this is going to be shifting the horizontal asymptote down 2 units. So this is going to be y equals -2. Is where I predict that this will be. So I'm going to just go down to and make a dash line at y equals -2. So I know I should be gliding across this line, whether it's this way or this way, however way it is. I know that the domain for all exponential functions are all real numbers. As far as everything else, I could try to predict the type. So the type here looks like the base is bigger than 1. So it could be a growth, but then I noticed that x here is negative. So anytime x is negative, this is probably a decay. So I predict that this is probably going to be a decay, but let's figure that out once we actually draw or make the table. So let's go ahead and make that t-chart. So remember, try to pick 3 points and always use 0 so you can find that y-intercept. So I'll just pick 0, 1, and 2. It's not going to matter too much. So if I plug in 0, this is going to be 3, -0. So that's just going to end up being a 0 and then a -2. So 3 to the 0 power is just 1. -2 is going to be -1. So make sure you follow order of operation. But it looks like when x is equal to 0, y is 1. So I know my y-intercept is 0, -1. And then I'm going to plug in 1 into here. So that's going to be 3, -1, -2. And so we've mentioned this before, but 3 to the -1 means that it's going to be 1/3 because that negative is going to throw that 3 in the denominator. So now that it's a 3 to the positive 1. And then there's a -2 here. So if I plug this in the calculator, 1/3 minus 2 is going to give me, actually, let's do that together in the calculator. So let me hit clear. If you want to do a fraction, you can always hit alpha, the green button, and then hit y equals. And so this will pop up and it will say frac, which means fraction. Just hit enter, and then you can get a fraction. So you can do 1/3, and then this is -2, and get your value here. So -1.67 if I round, or you could do 1 divided by 3 and then get that value and then subtract 2. So you can use division to show fractions. It'll give you the same number. So this is -1.67. So I'm going to round that to 2 decimal places since I'm just using a graph here to show that. And then 3, I'm going to be plugging in 2, so that's a 3 to the -2 minus 2. So this is going to be 1/3 to the second power minus 2, which is equivalent to 1/9 minus 2. So if I plug in 1/9 minus 2, so just showing that how to use that on the calculator one more time. So I can do fractions on the calculator. by hitting alpha, y equals, and then hit enter. 1 over 9 minus 2 is going to give me negative 1.89. So going back, this is negative 1.89 if I round to 2 decimal places. All right, so from here, I'm going to plot my point. So it looks like at 0, it's at negative 1. So right about here. And notice that like the original graph, if you look at the graph before at x equals 0, it was at 1, right? Whereas our x equals 0, it's at negative 1. It's shifted about 2 units down because of the y-intercept. It's shifting it down 2 units. So shifting all the points down about 2 units. So this one here at 1, positive 1, it's about negative 1.67. So I'm going to do my best to kind of draw that out, but I would say like right about there. And then at 2, it's negative 1.89. So that's really close to negative 2, so about like right there. So we can definitely see that this is causing it to get really close to that asymptote. But this side, you can tell it's probably going to grow upwards. But this here, notice as it's going to positive infinity, it's decaying. It's slowing down. The growth is slowing down. So this is an exponential decay, and it's also in going downwards like this. It's like decreasing. So this is a decay, and it's also decreasing. There are decays out there that are increasing. We just might not see one in this case. The range here, it's going from negative 2, y equals negative 2 to this way upwards. So infinity. So it's going from negative 2 to positive infinity. So you're asking yourself, how low does it go and how high does it go? And that's it. Let's try out the next one here. So this one here, I can see that there's a minus 2 here. So if you guys look at the definitions, whenever you have a minus 2 and it's the exponent, you're going to have a horizontal shift, and it's probably going to go right 2 units since it's a minus 2, but that's not going to be it's going to be hard to shift, so it might be just easier to make a t-chart graph. So first things first, the horizontal asymptote, notice there isn't a vertical shift here. So I know that the horizontal asymptote is going to be at y equals 0. So I'm going to go ahead and draw that on the graph. So make a dashed line here. It's going to be y equals 0 for the horizontal asymptote. And then domain for all exponentials are all real numbers. Oops, all real numbers. I don't know the range yet until I make the graph. The y-intercept, I don't know. If I were to predict the type, I noticed that b here, the base, is a 3, so it's bigger than 1. The base is bigger than 1, so that tells me that it could be an exponential growth. And also x here is not negative, so this is probably a growth, but we'll see. So let's make a t-chart. And I'll throw in my usual numbers, 0, 1, and 2. So if I plug in 0, this is going to end up being 3 to the negative 2, which ends up being 1 over 3, 2 in the denominator. So the negative exponent causes the 3 to be in the denominator. And so this is really 1/9. Or you guys might remember this is about 0.11 when you put it in the calculator. So if you take 1 divided by 9, you get about 0.11. If you plug in 1 in for x, you get 3 to the negative 1 power, which is 1/3. And 1/3 is about 0.33. And then if you plug in 2, 2 minus 2 is 0, so 3 to the 0 power is 1. All right, so now that we have our numbers here, let's go ahead and plot these points. So at 0 here, it's about 0.11, so it's like a tiny bit higher. And then at 1, it's about like 0.33, so a tiny bit more higher. And then 2, it hits 1. So right there. So this side is growing upwards, but this side is like definitely slowing down and getting closer to that asymptote. And so we definitely have an exponential growth because as it's approaching positive infinity, as it's going this way to the right, it's going upwards and it's increasing in the positive region. So you can definitely say this is increasing in value. The y-intercept, that's where x equals 0, and it happened to be at 0.11 is the value that we calculated for. So 0.11, or you could put 1/9 if you want to be very accurate. But I'm fine with the decimal. It's easier to read. And then the range here, it looks like it goes from 0 to positive infinity. So the y here, the lowest y value gets from 0, and then it increases to positive infinity. So 0 to positive infinity. And there we go. Our next one here is a fraction as the base. So we mentioned before, if you have a base and it's between 0 and 1, you probably have a decay. So I predict that this is probably going to be an exponential decay, even though x here is positive for the exponent. But if you have a number in between 0 and 1, you'll probably get an exponential decay. All right, so in this case, let's write down what is our horizontal asymptote. So it looks like we have a 1, a plus 1 here. So we have a horizontal asymptote at y equals 1 because it shifts it up 1 unit. So let's draw a dashed line at y equals 1. And then from here, what else do I know? I know that the domain is all real numbers. And I don't know the range yet. So let's go ahead and make a t-chart to find the points. So I'm just plugging 1, 0, 1, and 2. So plugging these values in, I do have a fraction to deal with. So if I raise 1/2 to the 0 power, this is just going to cause it to be 1. So 3 times 1 plus 1 is 3 plus 1, which is 4. So 1/2 to the 0 power is just 1. 3 times 1 is 3 plus 1 is going to give me 4. By the way, you can plug this all in the calculator too. So 1/2 to the first power is going to cause it just to be 1/2. And 1/2 times 3 is going to be 3 over 1/2 plus 1, which ends up being, if you convert 3 halves to decimal, that's 1.5. So that'd be 2.5. And then I'm going to plug in 1/2 to the second power. So if you take 1/2 to the second power, this ends up being 1/4 because you would just take your 1 and square it, and 2 square it, that gives you 1/4. And so 3 times 1/4 is 3 over 4 plus 1. So if you add these together, 3 over 4 is like 0.75. If you add it to 1, it's 1.75. All right, so we're ready to plot now. This one here is at 0, 4, so really high up about here. And then at 1, it gets down to 2.5, so it's going downwards. So 2.5 is right there. At 2, it's at 1.75, so a little bit lower than 2. And then this is going to be a horizontal asymptote as we glide to positive infinity. So I definitely see an exponential decay. This is slowing down as it's approaching to the right. So this is a decay, and it's decreasing as well. So this is decreasing. And then my y-intercept, that's where I plugged in 0, and that's where my y value ended up being 4. The range here goes from, looks like +1 for y to positive infinity. So 1 to infinity. And that's it. We have our graph. All right. Now we have this graph here. So it looks like we have a +5. So this is our vertical shift. It's going up 5 units, but it's also our horizontal asymptote is going to be at y equals 5. And so I'm going to draw the horizontal asymptote and make a dash line. And then we have a negative in front, so that will make things interesting. But what I'm going to do is try to predict what type of graph this is, if it's growth or decay. And so my base here is a 2, so that tells me it's a growth because it's bigger than 1. And also the x here is positive. And so the x is positive, the b is bigger than 1. So I think it's a growth, but we'll see if that ends up being the case. So who knows? Domain is going to be all real numbers because the domain for all exponentials is all real numbers. Let's go ahead and make a table. So I have my x, 0, 1, and 2 that I'm going to always choose. You can always switch it up and choose different x values. And if I plug in 0, that's -3, 2 to the 0 power plus 5. So 2 to the 0 power is going to give me 1. So that's going to be -3 times 1, which is -3, plus 5 is going to be +2. If I plug in 1, that's going to be, let's see, 2 to the first power is just 2. 2 times -3 is -6, plus 5 is going to give me -1. -6 plus 5 is -1. -3, 2 to the second power. So I'm going to plug in 2 now for x and work this out. So 2 to the second power is 4. But I have to multiply 3 and 4. That gives me -12 and 5. If I add this together, I get -12 plus 5 is -7. So it's getting quite negative. So 2, 0, 2, if I plot that, that's also my y-intercept, so I'll write that here, 0, 2, is about right here. Oh, let me do it in blue. So that is going to be my y-intercept. And then at 1, it is at -1, so down here. And then at 2, it's going to go down to -7. So I need to actually like extend my graph just a tiny bit. So I have room to go down that far. There we go. And so this side is like skyrocketing downwards, as interesting it is. And then this side here, it looks like it's going to have to approach the asymptote. One side's going to have to approach the asymptote. So this side looks like it's definitely moving down, so it's not going to touch the asymptote, whereas this side is going to be, looks like it's coming closer to the asymptote as it's approaching -infinity for x. So when I look at this graph, it looks like it's going downward. So that means that's going to be my lowest y value is -infinity, but it's going to grow upwards as you approach to this way. And so it's going to get to +5, but not quite touch it. So the lowest y value is -infinity. The highest y value is +5. So I have my range. As far as growth, this doesn't look like a growth, right? It's going downwards. But turns out this is an exponential growth. The only thing is it's growing negatively. So it's growing down in the negative region. So when we're talking about growth and decay, we're not necessarily saying that it's increasing or decreasing, because this is definitely decreasing. So this growth is decreasing in value because it is becoming more negative, but it's still growing because it's growing rapidly. So as x approaches positive infinity, this is growing more rapidly. And that's what we mean by growth, is not necessarily that it's increasing or decreasing, but that it's growing really fast as x is moving higher. So this one is tricky, but you do have an exponential growth, but it's just decreasing. All right, moving on to our last one here in this video. This is graphing natural exponential functions. So when it comes to graphing e, you do it just the same way. You can make a t-chart, and you can plug in some values. So I'm gonna plug in some more values for this one. And maybe do -2 and -1, and then a +1 and -2, and I'll throw in a 0. So I'm going to do 5 points just because E is a little bit trickier and I want to practice that with you guys. So I'm going to plug in -2 in for x, just plug in all the x values. So I'll use my calculator to get these values, but I know that e to the 0 power is going to be 1 because anything to the 0 power is 1. So I'm going to go ahead and plug in e to the -2 power into my calculator. And so grab a TI-84 calculator or feel free to use GeoGebra, but you're going to have to hit second ln, and that's how you'll get E on a TI-84 calculator. Put in -2 and hit enter. And so now I'm just gonna round to 3 decimal places, and I'll also do it for the next one here. So second, ln, and then I'm gonna type in -1, and then I'm gonna round that to 3 decimal places, and then let's do one for +1. So I already did one for 0. Okay, so it looks like a +1, it's 2.718, and then when e is to the second power, it looks like it's 7.389. So I'm gonna round them to about 3 digits to get our data. And so we're gonna plot these x and y values to see what e's graph looks like. So at -2, it's about 0.135, so like a tiny bit higher, but not quite half. And then at -1, also, it's a tiny bit higher. And then at 0, it's at 1. And then at 1, it's at 2.78, so a little bit below 3. And then at 2, it's at 7.389, so that's a little bit higher than what my graph is showing. So I'm going to extend the graph to maybe 7. And so extend that a little bit higher than 7 to represent 7.389, maybe like right here. And so if I were to graph this line, this is going to be shooting upwards. But this side is going to be slowing down. And turns out E also has an asymptote at y equals 0. And it works the same way. If there's like a vertical shift, then the horizontal asymptote will also shift along with it. So E works the same way as any exponential graph. And that should make sense because E is an actual number. Um, it is 2.718, and that's like the base. But it's written as a number because it has a lot of decimal points, and we don't want to write all the decimals. So the horizontal asymptote for E is also at y equals 0. The domain is going to be all real numbers because you can kind of see it's stretching to the left with an arrow. So it's going from -infinity. And it's also stretching to the right with an arrow. So it's going to go to +infinity. So all real numbers for the domain. As for the range, the lowest y value is at y equals 0. It's trying to get close to the asymptote. And then it's going to go to +infinity as y stretches up. So from 0 to infinity. And then the y-intercept is also at 0, 1 right there. And this is an exponential growth, as you can see, because it's moving upwards at a fast pace. So this is a growth, and it's increasing. All right, so that is it for the video. In the next video, we'll talk about solving exponential equations.